Hello. Okay, good morning, everyone. Let's start our lab today. And today we are going to talk about linear regression with gradient descent from scratch. Okay, so in previous labs, we are just using some library, like from Keras. So today we are going to make up our own functions by ourselves to understand deeply about the gradient descent and the loss function. Okay, so please first download our lab notebook today in week 10 and the data one that we are going to use today. Okay, then let's start. So the first part is it's the same with what we've done previously. We just load the library that we're going to use. And then also we load the data set. I think you are already quite familiar with these things. So in this data set, we have two columns. Actually, we only have like one feature and one target value. The feature is population, the target value is profit. So today we're going to find out the relationship between the population and the profit with linear regression. Yeah, and like this is just like what we've done previously. We have a look at some statistics related to the data set, like how many samples we have, and like what's the mean value, the standard deviation. And these are like the elements similar with the box plot we've talked about in the previous lab. This is just going to give you an overview of this data set. Okay. And then let's plot the data. Let's visualize the data. So this data.plot used before. So firstly, we define the type of the plot. So we're going to use a scatter plot. Scatter. And then the x values, the y values. Okay. And x value, we're using the population. Population. uppercase. This is just a name of the column, okay? And y value is profit. Profit. Okay. Yeah, here again, because we don't have header, we don't have the name of columns in our original data set in the txt file. So we put the names when we load the data set, which is population and profit. And we set the header as none, which means we don't have header in the original data set. So it will not take the first row as the header of the data set. Okay. And then we plot the figure. Something like this. We can adjust the figure size. Figure size. Figure size. You can design it as you like, okay? For example, we'll make it bigger. And change the size like want to be like a square, like this. Okay. We can do like this. Anyhow, you can choose your own size. Okay, and this is the distribution of the data. Okay, so this is the scatter plot. And then we need to create a loss function, okay, so to compute the loss. So as you're already very familiar with the loss function, you've already done your midterm, right? And here is the one we use, the MSE, right? So let's first define the part inside this function. Okay. So what to be? It should be the part here is like theta multiply x, right? We put like x multiply theta, theta. Theta. It's just like here, the transpose of the theta, okay? Theta transpose. And then this should be, we should calculate the difference between this term, h theta, and the y, right? So this is a difference of each data point with its target value. And then we need to calculate the power of it. So we can use the power library inside this NumPy power. So it's the square of this term, okay? So power of 2, right? It's a squared power of 2. And then it means we've finished this term on the right side. Then we need to calculate the sum of all these terms for each data points. So that's why we're using the sum here. We calculate the sum of the inner part. And then this should be over 2m according to the the formula, sorry. 2m. But what is m? M is the number of the data points, right? So it's the length of the x value. So it's like how many x value we have. So it should be like this. Yeah. So this is the cost function or loss function. Okay. Then here is set to add a column of ones to the training set. So we can use a vectorized solution to compute. What does it mean? So previously we only have one column. Now we add one more column. Why? This is because we have theta 0 and theta 1. Okay, so let's see, the formula is like this. Theta 0 plus theta 1 multiply population, right? And this is equal to the profit. So the function we are going to find is like this. This is a linear regression. So the function is like this. Profit equal to theta 0 plus theta 1 multiply population. Okay? And then we only have population in this data set. So how can we define the bias here? Theta 0. There's nothing to represent theta 0. That's why we put a 1 here. Then we can add an extra term of theta 0 in the following calculations. Okay, so this is the meaning of 1 here. For each sample is theta 0 multiply 1 plus theta 1 plus, multiply population. So it's just like we put a constant in each data sample, enable the calculation of bias in the following part. Okay, so this is the reason why we add a column of ones in the data set. No, we already have. Let me reload it. Okay. Okay. Then we need to initialize the data for the training data and the target data. Okay. So we just do slicing. We get the data from the data variable. Okay. So this data dot allocation is used to do slicing of the data frame. Okay. I think you are already very familiar with it. Used it many times. So the columns. What is the columns? This is the number of columns. We can run separately to see what it is. Okay. Sorry. Okay. The columns is 3. So we have 3 columns in our data set. Okay. And then for the training data, we need to take the first 2 columns. Right. So it will be like this: columns minus 1. So it means the first 2 columns. And then for the target value, the profit, we are going to take the last value, the last column. You can just put minus 1 to be the last one. Or you can use like columns, minus 1, 2 columns. The same, they're equivalent, okay? Okay. Then we just look at the head to check if our slicing is correct or not. So we have populations for the X. We have 2 columns, ones and populations. And then the Y head. like this, single colon. And if we change it to -1, just to check, just use the last colon. That will be the same. Okay. Yeah. So it will be the same. So it is equivalent. We can just put -1 to use the last column of a data set. Okay. Then we need to convert x and y to NumPy metrics for calculation. Okay. The data frame cannot be used directly for calculation. That's why we need to change it to arrays or matrix. We use the NumPy library, numpy.matrix. Just change the data type. X values. X values. The values from the data frame of X. Okay. Because if we check the type X, it will show you this is a pandas frame, data frame. Okay. And then let's first do it. X was a pandas data frame. And then we want to convert it to data matrix. So I just copy paste here. What? And theta. Theta we need to initialize by ourselves. Initialize by ourselves. We use an NumPy array. Okay. We create an NumPy array. And then the value was 0 and 0. And then if we check the type again, type X, then it will say it is an NumPy matrix now. Okay. So we've convert the X format, sorry, the type of X to NumPy matrix for later calculations. Okay, and we also initialize the value of the theta. We have two thetas, theta 0 and theta 1. That's where we have two values inside. We initialize them as 0. Okay, so we can also have a look at what theta is. Theta is spelled like this, right? Theta. It is a matrix which have two elements inside. Both of them are 0. Oh, sorry. We already have it here. And then we can also check the shape of the variable. So this shape is very important, especially when you are doing neural network in the next lab. Okay, so for our next lab, we are going ahead to the neural network. And when you are doing neural network, the input shape is very important. It should be fit the structure of the neural network that you design. Okay. So usually after we got the input, we need to check the shape. Okay, so we can see we have 97 samples. Each sample have two input, two features. And for the theta, we have one row, and each row have two elements. And for the y value, we have a single column and 97 samples. Okay. Then we just use the compute cost function. Okay. So the compute cost function we've already defined here. So we need to put x, y, and theta. Okay. So we just put x, y, and theta inside. X, y, and theta. X1, y. Okay. Check. report. Theta x theta y the power two of length x by some in. Okay. Okay. Probably. Okay. That's better. X and y for the y value. Okay. So the initial cost is 3,000. Okay, let's do it first. I check later. Doesn't matter. We check it later. Maybe it's a problem. I'm not sure. Okay, so the initial cost is 3,000 something. Okay, and then let's do gradient descent. So here we already provide you the code here, and actually it's quite simple. So firstly, we initialize some variables or some arrays matrix that we are going to use. Okay, so this is like the temp. It is used to get the value of the new theta. Okay, this is the value of the theta in the next step. And then this is the number of parameters we have. In total, we have only 2 parameters. Okay. If we do like this, parameters, we run this parameters. We will see it is 2. Okay. We just copy the shape of the theta. So it said we have 2 thetas in total. So we have 2 parameters. And then this is the cost for each iteration. Okay. So this is the array that we used to store the cost from each iteration in the loop. Okay. But then how many iteration? This is like the number of iteration we defined here. Okay, later we are going to do 1,000 iterations. And then in these 1,000 iterations, in each iteration, we calculate the error first. This is the error is this part. Okay, the error between the function value and the target value. And then we just update the theta, the parameter, according to the gradient descent formula. Okay, so we multiply this error with this x. Okay, well, xj is here. So xj is for each data point. So in total, we have j data points. So in each time, we calculate one of them. Okay, for each j in these 2 parameter. Oh, sorry, j is the number. J is, oh, sorry, j is the number of parameter. Okay, m is the number of data points. Okay. Yeah, so xj is the parameter for the parameter, j is for the parameter. So we multiply this error here with xj, and then we update the theta according to the result of this term based on the alpha. The alpha is the learning rate. Okay. And then these are the formulas here. Okay, so we just sum up the loss and then divide it by the length. Okay, and then after we got the update equation, we got this new theta, and then we store this theta, the temp. Actually, this is called temp here. So this is the new theta for the next step. So for each parameter, we have two parameters, theta 1 and theta 0 and theta 1. Okay, so they are all represented by theta j. And in the first iteration here, we update theta 0, and then in the second iteration here, we update theta 1. Okay, so every time, in each iteration here, we update 2 times. Sorry, 1 time for the two parameters. Okay, so this is the gradient descent function. And then we set the learning rate at 0.001, and then we do 1,000 iterations. Okay. So for the iterations, we can just write like this. We can just simply call this function x, y, and this function. Yeah, so the iterations is 1,000 here. The alpha is alpha here. And then we calculate the new theta. So it's like we get the new theta. Okay. We overflow. Yeah, I think there's some problem in the previous formula. Let me check it. It's the cost function. The type of problem. Yep. What's the problem? It's strange. X, Y, and Y. Uh, 0, refract cost function. Yes. It's first data point. Well, $254. Between is the type 0. But doesn't. Yeah, correct. Oh, why? Okay, then we can get okay. All data, all the data. Is correct. Oh, the shape is wrong. The shape should be 97 to 1, but it's 1 to 97. Oh, wait, where is why the shape is wrong? Oh, maybe we have to use, all right, maybe here we must use this one, or it will automatically change the shape. Okay, try this one. Okay, although you can see the head have no change, but the shape will change. It will be transposed. Yeah, now it's correct. Yeah, that's why I said you need to carefully check your shape before you use the data. Okay. So the shape should be 97 by 1. So it should be the same as the x, the first dimension of x. Previously, I use -1 directly. And then the head is the same. But the shape changed. It is transposed. That's why the calculation doesn't work anymore, because we're doing matrix multiplication, because we're using matrix here. Okay, and then we find the problem. Columns. Wait, columns. Okay. Okay. Then we do it again. Check. Yeah, now the shape is correct. And then we compute the, yeah, now it's correct. Because previous the loss is so big, it's a very spin. So now the loss is 32. Okay. And then we just run other things again. Actually, we already defined it, so even we don't run it, I'll have to restart. Okay, now we can see we have the new theta. Okay. So this is the intercept. This is the slope for this linear regression. Okay. So after 1,000 iterations, we got the intercept and the slope. Again, we calculate the cost. The new cost in the last iteration is 4.5 something. And then we already have the code here. We just run it. So it will be the line that fits this data. This is the result of the linear regression. Okay, and here's the function we use. So this new theta, if we check the new theta, we have two elements inside. So because it is a matrix, okay, so we can have a look at the shape. New theta dot shape. We can see the shape is 1 by 2. Okay, that's why we need to put two index here. Okay, the first is the row, the second is the column. Okay, so the first one is the first column, first row, first column, and the first row, second column. Okay, and the first column is the intercept. The second column is the slope. That's why we have it. That's why we use the function. We review the function this way. Okay, and then we just plot this function out in our previous plotting. That would be like this. Okay, and what's the last one? The last one is the loss during the iterations. So in total, we have 1,000 iterations. Okay, and you can see the changes of the error of the loss during these iterations, during these gradient descents. Okay, because in this gradient descent, we've saved the cost in each iteration. Okay, we create an array of cost, and in each iteration of I, we put the cost, the computed cost, in the cost array, in the i's elements of the cost array. That's why we stored all the cost, and then we print it out according to the index. And the index is just the number of iterations. Okay, then, yeah, that's part 2 for yourself. If you have any questions, please let me know. Provide 这里provide 正常那个情况应该1/7嘛，得7/1的，得7/1。然后刚刚说哪里转置的小把它转置成了1/7，然后它的形状就对不上，它到时候真看的时候就，哎，对对，因为你看这边是它这个计算后的形状是怎样的，然后它这个97/2乘以它转置都是2/1，对吧？最后这样对一个形状是7/1，然后你用7/1的形状去点一个1/1的，它就没法点，必须形状相同的这个方向列列型，所以它都没有。Okay, then it's the end of this class. Thank you very much and see you next week.